All right, folks, we're back. That was a quick 2 minutes. So we heard from Doug, Sean, and Sham about the COVID work in the test network, but let's put some more reality against that as we move forward for this work in the production network, as Doug mentioned, starting on Monday. So let's go ahead and kick off this session here around the work and production. So the goals for today, we have a lot, as you can see, to get through. But first, I want to run through and highlight the governance that's required to enable COVID-related research in the ACT production network. Then we'll move on to a little bit more detail around the specialized COVID ontology and what you can expect to be doing once you're moving forward with this in your possibly stage, but definitely production node starting on Monday. We'll talk through a few recommendations for increasing the frequency of data refreshes. Right now, most of you I know are only refreshing your data once a month. I shouldn't say only, I know that can be a lift. So we'll talk about what we're expecting in the production network moving forward, or at least what we hope you can plan to attempt to do in the coming months as far as increasing the frequency of data refreshes on your production node. And then we'll highlight some future items, namely around data characterization and quality, and then even skip ahead to the future of ACT. And then we should have some time to address any questions you have. Keep the Q&A going, and as always, send me an email directly with any questions that you have following the session. Okay, so our governance work is still a little bit in progress here. We do have our next ACT governance work group coming up next week. So if you see anything here that you feel might be concerning to your institution, or if you have questions that aren't addressed on this slide, go ahead and send me a note. We won't be addressing any governance related questions live today since we have our work group meeting coming up next week. So I'll have the opportunity to take any of your questions or concerns back to that work group so that we can assure we're addressing and thinking through everything properly before we go ahead and roll this work out to our production network. And when I say this work, I mean the governance documentation. So the main point that I want to call your attention to for both the network agreement and the governance document is that what's currently represented there is not changing. So the ACT network will still function the same as it always has. The expectations are the same. However, we are adding an addendum to the network agreement that will allow for COVID-19 related clinical research and data analysis. And then we will ensure that the language is updated as appropriate in our governance documentation. So this includes the actual governance document and also the terms of query access that you have your end users agree to before they have access to your production node. So in addition to just allowing COVID-related research, one of the other big items is more of a definition around a publication committee that will be the ones reviewing any manuscripts that are moving forward to publication. So that is the biggest change that you'll see coming with our governance document. But like I said, we hope to finalize that soon, and we will share with you that information once we have it. But please let me know any questions that you might have via email. All right, over to you, Sham. Sean, I think you're still there.
Can you hear me now? I think I'm.
Yes, sir. Thank you.
Muted. So I'll give a brief overview of the ACT COVID-19 ontology. So this is being developed specifically for COVID-19 related querying, and it's rapidly evolving. And the way we architected is that this would be an additional tree to the other standard ACT ontology trees so that the updates can be pretty quick, where it doesn't touch the other trees of the ACT ontology. We've released 3 versions so far in the past couple of months. So currently we are on version 3, and this version is available for download and installation through the GitHub repo. Next slide, please. Next slide, Elena.
Are we on goals? Do you see it?
Okay, yep, it did shift. Okay, so the goals that we have for the ACT ontology are to include, number one, the emerging codes. So there are new COVID-related terms, which you find in the standard terminologies, which includes ICD-10, CPT, HCPCS, and especially LOINC. So LOINC produces a handful of new lab codes every week, so which are relevant to COVID-19. So one of the challenges in developing this ontology is that we need a rapid release cycle to be able to capture all the new and emerging terms that are relevant for COVID research. The second goal was to gather and pull together codes which already exist in the standard ACT ontology trees elsewhere. So these would be diagnostic codes in ICD-10, procedure codes in CPT, medication codes in the RxNorm trees, which are particularly relevant to COVID, and gather them and pull them together into the COVID-19 ontology so that it's far more convenient to use. And then the third goal was to create derived terms which are of particular interest in COVID-19 research. So yeah, an example of this would be like illness severity or mechanical ventilation. And the idea here is that we are now moving into the realm of computable phenotypes, where we define illness severity, mechanical ventilation in terms of existing codes, as I will show in a future slide. Next slide. So here's an example of a computable phenotype, which is incorporated into the ontology itself. So under the course of illness, we have one concept, which is severe illness, which you can see in the middle of the slide. And so we have defined severe illness as somebody who is undergoing, say, mechanical ventilation. And there are various ways to infer that someone might be on mechanical ventilation. So these include lab tests, which are looking at, say, arterial blood gases like carbon dioxide or oxygen, for example, or the use of medications for anesthesia when you're in mechanical ventilation, as well as diagnostic codes and procedures which might indicate that you're being mechanically ventilated. And in fact, mechanical ventilation does get coded at the end of the stay. In addition, which is indicated by the red arrow, we also have this derived term called severe illness. And this is of use when you have a patient who's currently in the hospital and you're drawing data from the EHR, and you might be able to infer that this person is on mechanical ventilation, but it's not yet coded up using, say, ICD or CPT codes at this point. And so you would attach a date stamp to that fact and give it the code. We basically use a specific code, which sometimes is a UMLS code for this derived fact. And so what this helps us, especially the user, to do is that now you have this concept called severe illness, which makes sense in the context of COVID. And the ontology does quite a bit of work where it has collected all the codes that go into the definition of severe illness and includes this derived term. And so just by dragging over severe illness in the Shrine interface, you're now able to get to the core of people who have severe illness. And if a user feels that there should be other concepts included in the severe illness, then it's easy enough to drag in these other terms that might be of interest in that definition and pull them over too. But this acts like a starting point for this computable phenotype severe illness. Next slide, please. Okay, so we have the ACT ontology in the deployed setting, which is currently on the COVID test network. We also have this on a demonstration server, which the work group uses to look at and make modifications, and that's the URL that you see. What I'm going to do is I'm going to try and log into the test network, the COVID test network, and show you briefly the ontology.
Shyam, I'll stop my screen share so that you can start yours.
Okay. Okay, can you see the Shrine interface?
Yes.
Actually, the I2B2 interface at this point.
Yep.
So this is what you would see if you were to log into the ACT COVID network. What you see on top is the ACT COVID ontology, and then the rest of them are the standard ACT ontologies. So this is version 3, as you can see here. And we have the course of illness, the diagnosis, and the diagnostic lab tests as the top level concepts currently. Let me show you briefly the lab tests. So this group of concepts are all derived from LOINC. And this is the part of the ontology which gets updated pretty frequently as LOINC introduces new codes for the new lab tests. And so all the LOINC codes are separated into 2 groups. So you have lab orders. So these are various kinds of orders that you can put in for testing for the COVID virus. But of greatest interest are the lab test results, which we have grouped into these 4 categories at this point based on where the specimen comes from. And so under each one of this, you have various LOINC-coded result values. And as you can see, we also provide this harmonized value, which is positive, negative, pending, and equivocal for all the lab tests which are categorical. And then in addition, we have at this level a harmonized set of 8 values. 4 values are for lab tests which are looking at nucleic acids, which are the ones which are commonly used at this point, and then the antibody tests which are coming along. And the idea here is that when data gets loaded in, we would like to have the sites map their values to this set of 4 values, positive, negative, pending, or equivocal. And once that is done, the user can then use it at this level and drag over, for example, any nucleic acid lab test positive. And this would get to any SARS-CoV-2 test which has a lab result which is positive. So this makes it relatively simple to query the data, where you don't have to run through all the possible labs. This takes care of all the labs which have been loaded in. The other interesting concept level is the illness severity. So illness severity is, so we have basically 3 levels of this: death, which is basically a simple single concept, and then moderate illness and severe illness. And these are, in a sense, computable phenotypes that we have defined. What they have under them are either regular codes that you would get out of the EHR, like CPT4 codes or ICD-10 codes, as well as a derived code, which you can use to map your local EHR data if it's not yet been coded to this particular value. So then we can use moderate illness as a complex concept or a higher level concept, drag it over and look for moderate people with, say, moderate illness or in combination with other facts. So the diagnosis part of the ontology was developed early on, and this was based on CDC criteria when they had defined these concepts like confirmed case, suspected case, and symptoms indicating a suspected case. And these are all based on codes from ICD-10. Most of them are from ICD-10. Actually, all of them are from ICD-10. So this is probably more relevant if you're coming in from a public health perspective, and these cases are defined in this way. But this is also changing, and so at a future time, we might change these definitions of confirmed case and suspected case. And then finally, we have this element called the total patient count. And what this does is it basically tells you the total number of patients that are there at a site, which has been loaded into this particular I2B2 repository connected to the ACT COVID network. And this provides the denominator that most of the times you might need to understand any of the other queries. So if you want to know what fraction of the patients have had a COVID test, then you would use any lab test, these 8 values, and look for people who had one or more of these values. And that would be the numerator, which tells you that these are the people who have had a COVID test. And then for the denominator, you get the total patient count, which tells you the total number of patients at that particular site. And I think with that, I will stop.
Okay, back over to the slides. So Shyam, are you going to talk a little bit about the data refresh that's expected?
Yeah. So the ontology was, one of the challenges with the ontology was the emerging terms and the fact that we have to quickly refresh the ontology and put out new versions. In parallel, we also have the challenge of data refreshes. And at least initially when the pandemic began, it was imperative that we had frequent data refreshes compared to the current rate of once a month, which is what the production network and ACT uses. And so in the ACT COVID test network, the refresh rates vary from daily to 2 to 3 times a week. And the challenges for these frequent updates of the data is that it depends upon the particulars at your site. So most sites would probably be drawing the data from a warehouse, and the warehouse may or may not be refreshed daily, for example. And so you're kind of dependent on that warehouse in terms of your refresh rate. A second challenge is that if you have a very large I2B2, then refreshing the I2B2 overnight on a daily basis could be a challenge. And the third challenge is that when you are drawing data on patients who are still in hospital, the coding can be incomplete because most of the coding, a lot of the coding happens at the end of the visit. And so you have to do a lot more work in terms of mapping the data to the terminology and the standard codes. Next slide. So this is a snapshot of the 9 sites in the current ACT COVID network. And you can see that these sites vary from once a day to twice per week in terms of their refresh rates. While some sites are able to refresh their entire I2B2, there are other sites which only refresh a particular subset which are relevant to COVID. And I'll talk briefly about how we define that subset. Next slide, please. So if you're a site who have a smaller I2B2 database and you have access to data which is available pretty much on a daily basis, then you can refresh the I2B2 data mart pretty much on a daily basis. However, if you're a site which has a very large I2B2 and it's challenging to refresh that overnight, we developed an ACT COVID-19 phenotype, which basically defines the patient cohort which we would like you to refresh more frequently than your full cohort. And this is basically based on COVID-related codes or COVID-relevant codes in ICD, CPT, and LOINC. And this definition also expands and gets revised in sync with the ontology, as well as in sync with other efforts which use a phenotype definition. And the current definition is available in the GitHub repo. Next slide, please. So this basically lists the current set of codes that we use to define the phenotype and essentially define a patient as COVID relevant if one or more of these codes are there in that patient record since the beginning of the year, which is January 1st, 2020. Next slide, please. So I guess that ends my section. Yeah.
Thank you so much, Shyam. So this is really just a different version than what Doug shared if you participated in the first session. So I'll make this quick. There's 3 points that I want to make here. First is just reiterating that the ontology move to 3.0, which includes this COVID ontology, starts on Monday. So that can be accessed from the GitHub. Second, the I2B2 and the Shrine release, they will be coming later this summer with dates TBD. But third, I will use the technology distribution list as the source of truth for what you're supposed to do when, next, what's happening over the next few weeks. So do be on the lookout for an email from me on Monday by the end of the day that has this information here for you, in addition to a tracking spreadsheet. So you can keep us posted as you continue to move through this work on your production node. So very excited to finally be rolling this out across production. I know many of you have been waiting to put this into your production node, and you know of some end users who are looking forward to having this ontology available in ACT. So happy to be making it happen starting Monday. Okay, over to you, Michelle, to talk us through a preview of what's to come later on with data characterization and data quality.
Okay, so as a part of this COVID effort, we're also going to be doing some data characterization and quality, and it's going to be kind of a two-pronged effort happening starting now. We're going to take advantage of everyone's interest in COVID for a portion of it, and the rest will be some data quality checks and analysis on your full ontology. So what we want to do is, as Sean's going to talk about later, we're trying to move ACT in a direction where it's prepared to do research and not just cohort discovery. So what we want to do is to be able to understand our network data better. We want to be able to know what data we have, you know, site by site, and we want to be able to know, do things like know if an age group is not available at a site because it's just a pediatric organization, or whether or not your site has cancer data, or what the start dates of your data is and the end dates are. So we want to be able to know these things so that we can put it out so that the researchers will be able to interpret their query results. The second thing we want to do is want to assess how well we're harmonizing to the ontology and to each other. So one of the projects we're doing with that is in the data harm working group led by the Mayo team is we're trying to harmonize and understand what links are being used at the various sites. And so we have 20 sites who submitted their lab data and the counts of how many labs they've used. We're going to be using that data to try to figure out how to better create a lab ontology, but it'll also let us know what the coverage is in our labs and how to direct people to use the ontologies to do querying better. And then the last thing we want to do is be able to assess the quality of our data. So next slide. We're going to be doing two things. So this is something you're all very familiar with. This is our ACT data characterization survey where everybody expressed what gaps they had, how much data they had in the various domains. So we're going to be taking a look at this along with, next slide, doing thousands and thousands of query across our network. So since we are a real-time network, we're going to be able to, from a central place, pit, run thousands and thousands of query to kind of get the counts of a lot of the elements within the ontology. And we already started. So you'll see a lot of queries and they'll say data harmonization as the query topic probably. But we'll take this data and we'll do different percentages. And next slide. Start looking at some of the quality issues. You know, if people have things mapped, like on this slide, for example, we know that these two sites actually do have children and adults, but they didn't map it to that particular ontology term. So we'll be highlighting missing mappings. Next slide. We'll be identifying outliers. Next slide. We'll also be looking very closely at sites who are chronically down. So that's the other thing. We would like for people to make sure that they're checking periodically to whether or not their site is responding to queries. We have some sites who stay down for weeks and months, and we don't want that to be this, you know, what's going on. So what we're going to be doing is we're going to be taking all this data from all the queries, we're going to be analyzing it, and what we'll do is we'll start interacting with the sites and pointing out the different areas where we think they may be able to improve. We'll be looking at it in terms of harmonization, whether, you know, people are using the same term the same way. And so you'll be hearing from me and Philip and maybe Muller, where we're going to put together a bunch of reports and you'll be able to see how your data relates to the rest of the network and to help everybody clean up their data and get it in good shape. And hopefully we'll be able to move towards research. Next slide. So at the end, which these are actually real numbers from what we have right now, we will be able to do a nice characterization of what's in our network. We'll be able to say, you know, over the years, this is how many diabetes patients we have, cardiovascular disease. We'll be able to say we're prepared to do cancer research on these various areas and know how much data we have available. We'll know our distributions of ages and visit types. So these are the types of things that we're gonna do in a semi-manual process, but I think it'll be informative and it'll make our network stronger. And then the second part of our data quality project, Jeff Clan's gonna talk about.
Hey guys. Oh, I'm echoing because I am on my phone also. Hang on, let me turn that off. Sorry. Too much technology. Okay, so I'm Jeff Clan. I've only been mildly involved in ACT until this year, but I did a lot of the technology for the Arch network, and we did this in the Arch network. And for those who don't know what the Arch network was, it was a PCORNet network that was funded at Harvard. It had sites all around the country, and it used many of the same technologies. It used I2V2 and Shrine, so a lot of parallel things. So now we're talking about implementing this in the ACT network on the test network for COVID data quality. And we've already begun this process. So this is about counting the total number of patients with items in the ontology. So this is a simple way of doing thousands and thousands of queries without a lot of resource impact. So you can, I2B2 has had in its data model for a long time the ability to store the number of counts with things. Oh, Elena, can you go back a slide? Or I think maybe the timing is on or something, and I just talked for too many seconds.
I think you're right. I'll monitor that.
Sorry about that. I should turn that off. So I2B2 in the data model has had the ability to count the number of patients with things for a long time, as far as the data model was concerned. And now we have scripts that I've been spending a lot of time enhancing that will very rapidly count the number of patients with every item in the ontology. So you can look at high level of things like medications in this obfuscated view. You see that our site has 45,000 patients in this cohort with medications, but just 4,000 with angiotensin II inhibitors. So you can get kind of a nice view of everything that's going on in the network, even though these are basically just like one item queries. You're querying for every one thing. And you can run this on your local site. You can integrate it in your ETL if you want. And it runs on our COVID ontology in like 2 minutes with the COVID data set. If we wanted to run it on the whole ACT production, it takes a couple of hours. And we're trying to get, Postgres is now about at the same speed. Oracle's a little bit slower, so we're trying to get that back up to speed. It's producing, it annotates the ontology, so you get this data for yourself in I2B2. It also creates an obfuscated reporting table that you can just export. And there are clever ways Michelle has been playing with to get this data out through Shrine, but for right now, we're just going to have the test network export that to a CSV and send it to us, which I know is like an extra step, but it does save save running all of these queries. Okay, so next slide. So this is just, I've talked through most of this, but we're going to distribute these total num counting scripts. Michelle put them on the site with the latest ontology, so you can grab those and start working with them if you want. And then the sites will contribute back the counts to an aggregated repository, which right now is going to be my email address, and will eventually turn into something more sophisticated. I have code that smushes those all together into an aggregated report. Again, the reports that the sites are submitting are all going to be obfuscated in the same way as the Shrine queries. So they're all going to have the same privacy protections there. And then we can start to do analytics on it. And I didn't put a lot of analytics slides in here because the things that Michelle just showed are this kind of the same types of things that we're going to try to do. We're going to try to look for outliers across sites. We're going to try to look for issues refreshing data across time. And we're going to try to look for missing things. I've also been working on a dashboard to view this stuff. So yeah, Elaine, if you can play that video. So this is an early alpha version with a very ugly ontology browser, but it's very functional. And so you can kind of imagine if you were in the I2B2 ontology browser, you can kind of dig in at deeper and deeper levels and look at the comparison across sites. And this just has MGB and PIT data, but as we get more data sets, this will become more interesting. And so you can compare the different positive, negative lab tests. You can dig into positive lab tests and see that there were, most of our counts at MGB come from the 943092, which is my favorite point code right now. Okay, so, and then there's one more slide. Yeah, I think you have to yeah, there we go. So this is an example of what we can do once we have more data. So each data point on here represents a data refresh. And so you can see that you would expect data to go up over time as you refresh your data. So this is, this kind of highlights the advantage of doing somewhat frequent refreshes, because you can look at the number of patients with things going up. Even though patients get better, the number of patients with historical data should always be going up, right? So this top line is low quality, because something is wrong with the ETL because the patient count is going down. The middle line is higher quality because you see things going up. So that's the kind of thing that we can detect automatically just from these simple reports of single things. And so that's what this initiative is trying to do, to see how much leverage can we get from data quality just by counting all of the single things. And we can do that pretty rapidly, we found. So I didn't talk too much about logistics. I think Michelle is better to do that, but the scripts are available and we're going to start asking test network sites to run this in the near future.
Yeah, actually, we're hoping that people will be able to run them right after they do their first ETL with the COVID ontology in place. So we'll be able to get that initial snapshot of the counts from each of the sites, and Jeff can start on his work. So, and there'll be more instructions coming from Elena regarding that.
Mm-hmm.
Very cool. Thank you, guys. All right, Sean, back over to you, and let's give this about 10 minutes. So we have some time for questions.
Right. So Jeff and I prepared this presentation for yesterday, but for those who weren't there, I thought maybe we could walk through it just very quickly and understand what the future that we're looking at for doing research in ACT would be. Now, I want to make it very clear, and Carl Burke was on the Q&A session and asked a very good question, which is this all going to be required? And the bottom line is what we're coming together in the ACT network is to put in the ontologies and to work towards. And so if you look at the next slide, I guess it lays it out a little bit better. On the top, you see, we want to prepare the network to query for sites and see if they have adequate data and if they have well-prepared data. But the actual participation in this research can be pretty heavy sometimes. It can result in, people actually needing to go in and modify, some of the scripts that we might give them, conjure and think of the right way to do it in their system. Lots of different codes are at the raw level in your systems that only you know of, and that should be used, for example, to outline an ICU stay, and I'll go into that a little bit more in a minute. So really, for effective research to happen, for us to control for confounders and aberrations that occur in systems, and to do quality and validation checking, that is, to make sure that the results are consistent with what you see in the EHR, chart review, the results and so forth, that's going to take a lot of local work. So the local work translates into researchers, that is you all, at the sites. Participating in this research is an amazing way that we can actually provide COVID-19 inferencing, but also, on lots of other diseases and situations as we go forward. And of course, the attribution is key. And so what we're really emphasizing also is this publication part, which is all the folks that are involved in doing work at the sites can actually participate actively in the publication as it forms, so that everyone feels, rewarded, and, the appropriate advancement of you also occurs. Next slide. So the first part is these quality control charts, and we always need to start with quality data. And in some ways, that is about just checking to make sure that the loads occur properly, that the data seems consistent in every way that Michelle and Jeff just outlined. And so you just to re-show Jeff's chart. We expect this orange line to be occurring, a nice gentle increase in the number of counts for a patient on every ontology item, and not a decrease or a sudden drop, as you can see in the poor quality excerpts. So that's kind of the first step to see, are we prepared for doing research at a site? Next slide. Second is the creation of these derived facts, and this gets pretty involved. There's kind of two kinds of derived facts. Ones that are basically additions to your I2B2 ontologies, which is the facts that occur over time. And often we're grouping them in new ways. So just like Michelle showed you and Sham showed you on that last presentation, a lot of times we're trying to group these into new different ways of expressing them, but it doesn't involve creating new data. You also can create new level 1 facts by simply taking data that you're not yet ETLing into your I2B2 and making special efforts to ETL it in. So that's where local knowledge and expertise comes into play to get that actually into your I2B2s if it wasn't there before. And things like transforming the lab test so that now it can be queried in that unified state rather than lots of different kinds of text items that are all unstructured. Natural language processing kind of falls into this level 1 fact, where you're trying to excerpt things out of text and put those in as facts into your I2B2. So lots of ways that research might want to take advantage of putting in these level 1 facts, new facts from groupings and so forth that would go into your I2B2 and could be queried through the Shrine. Second is the level 2 facts, and level 2 facts are, yes, that was great, Elena, good job. Level 2 facts are, you take a lot of the raw data or the level 1 facts and you aggregate them together. And so what are level 2 facts? They're usually very specific to a study that you're doing. They can still be put in your I2B2, but often they're around an index date. For example, it will be something of the nature of, what was the maximum lab value after the COVID test was done and before they were discharged from the hospital? So it's kind of like, it's a fact that embodies a lot of these temporal elements. And these temporal elements often involve an index date that gets well defined, the COVID test date, for example, or, you know, when somebody was enrolled in a program, there's lots of ways that an index date occurs, and then some kind of summary of before the index date perhaps and after the index date into these aggregate values. And these level 2 facts, next slide, can be derived, we'll have a fact, level 2 fact generator, and that's essentially what we've been working on in ACT that will be distributed shortly, that can make some basic things like, let's say we want to get the first date of your diabetes diagnosis, right? And put that into a table. That's essentially a level 2 fact. Next slide. And it goes into one of these analytic tables, which are one subject per row where the data has been digested out. So here, your patient 104 has their index date, their first date of diabetes diagnosis, and then since then, their most recent A1C and so forth, and their average A1C since that time. So that's what these tables then get put into the level 2 facts, can be transformed or pivoted into these analytic tables, and these analytic tables will then go into the next step, next slide, which is actually sharing analytic scripts and adapting them at times to doing the research at your site. Now, often the results of that research can be put back into the into your I2B2, and that a typical result of that is like a computed phenotype. So that's one result. Or you can have results which are specific about how many patients were severely affected by COVID, if you're worrying about the severe disease definition. Next slide. And so we put a lot of work together in terms of trying to understand what different things in the chart could be used as definitions of severity. So things like anesthesia medications, indicating that you're in the ICU, cardiac medications that would be used in the ICU, arterial blood gases, and so forth. And in the next slide, we're looking to say, okay, let's really develop that definition like a phenotype, like Sean was saying. Develop it like a phenotype. And what can we do to actually validate that our severity definition is actually working? Next slide. So we compare it with other data, often data that we need to review from the chart. And in this case, we're comparing it to those patients who are in the ICU or died, right? And saying how many patients who we gave that severity diagnosis to were in the ICU or died, how many did not? If they were not diagnosed as severe, how many were in the ICU and survived or died? And if they were not classified as severe, how many were not in the ICU or did not die? And so you make that 2x2 table, and then you can calculate the sensitivity, specificity, positive predictive value for your severity code and negative predictive value. And what you can see is in a couple of, it's not always the same, right? So in sites A and B, the positive predictive value for the severity codes is pretty good. In site C, it wasn't quite as good, right? And along with that, the specificity in site A and B of that definition was pretty good, and site C it wasn't. So the fact is we need to do this at many different sites to put it together and then optimize in the next slide using a conventional kind of almost phenotyping approach, which is let's just plug the numbers in, plug in our chart review results or our gold standard, whatever that might be, and compute what is it, what are the features that actually make the most sense in creating this definition. And you can see that I heavily relied on, in one site, this arterial carbon dioxide. It really comes out, right? Arterial carbon dioxide was probably the most important thing in this site for the severity definition to give you accurate results. And then some of it was what on the norepinephrine that was given and so forth, and some arterial different tests. Next slide. And of course, we can put this kind of thing on a receiver operator curve to really kind of home in on the right sweet spot that we're looking for on that receiver operator curve for our definition. Next slide. Next one. So that's going to be a very important part of what we do, and this is really it was really embodied in recent events where we found that EHR data that wasn't properly validated, that there was not the proper participation in the researchers at the local sites, really resulted in very poor papers. And so what we are really looking to do is have a lot of voluntary research, right? People that want to be included, we know, where their data is prepared from the Shrine queries, and then those folks will have the opportunity to participate in a lot of these studies. And that's really the blueprint for research with ACT. Next slide. And of course, we're making every effort to come up with really nice methods to create community papers as we go through this research process, so that the groups working on that research can start writing the papers right away, pulling the results, in Google Docs and GitHubs and so forth. Next slide. Finally, in terms of pooling the data, we've been looking at what are the different ways that we could take the small counts that come off of many of the sites and put them together into an aggregated analysis. And two methods have come kind of to the forefront, and we'll all be looking at these to see if they satisfy us. Homomorphic encryption, we have the participants from Switzerland and in the MEDCO organization. And then there's another way of pulling together small cell sizes called secure multi-party computation, where each small number that you have at your site is split into two addends. Let's say one is split into -3 and 4. You send a -3 and 4 to two different sites. Everybody sends the two addends to two different sites, and then they're added up at the site, and then they're put back together and added up in the middle. And it's just taking advantage of the associative property of math, but it preserves the privacy of all small cell sites, because no one knows at either of those aggregation sites what the total sum is. And it's not actually known until you put the number all back together as one. Next slide. So what we're hoping is that we should be able to implement these methods. We should be able to really find the sites that are ready to do research and then offer them these opportunities for being able to do research at some of the most highly talented, I should say, places across the US, right? Because in the CTSAs, in our program, are some of the most highly talented researchers that we have. And so offering opportunities to all of us to get together is, I think, where we really want to go with.
Excellent. Thank you so much, Sean. Very exciting. Things to look forward to. All right, guys, we have about 5 minutes to field a couple of questions before we break and get ready for our next session. I see quite an active chat here and a Q&A. So let's see. let's take it from the top in the Q&A here. So from Keith Elliston, how much of a challenge is it for AMCs to update their I2B2 instances 2 times a week or daily? Are there any standard tools that enable this to run in an automated or semi-automated mode? Who wants to take that one?
So I don't know of an automated way. There are, Epic does have certain flow sheets that you can use as perhaps some of the gold standard, but there's nothing like chart review to actually go in, look at the chart, compare them to what you have in your database and kind of assess the validity that way. Because especially in the fog of war, where lots of different things might be happening to your systems, and patients going different places on new kinds of machines that they just got in because they had to get new ventilators in to fulfill the need. It can be tough, and that's where studies can go wrong. So being able to do that kind of validation using chart review and so forth is really, really important. It's hard, but it's important.
Great. Thank you, Sean. And then this question from Carl. Sean, I think that you had touched on part of this just related to the specialized ontologies that may be updated with a higher frequency than what we typically see across the network, and the possibility that the same approach could be used for future research. So the question around, will all sites make all modifications to the ontology and ETLs as they come in, or only if asked to participate in the research based on other prep work? So I'll take a stab at that, and others please chime in. So right now, the ontology, we're seeing this release and any future releases, at least as it relates to the specialized COVID ontology, as just being part of our release plan for the production network. So we're treating it just like any other ontology release, even if for whatever reason locally you won't be enabling your researchers, if it's for governance related issues or otherwise, to actually conduct research using those new terms. But in the future, we'll keep anything that's prep work related in the test network, and anything, assuming nothing crazy happens in the next couple of months, I'm assuming that just the COVID work will be the only thing that's specialized rolling out across production as far as the ontology goes, and then anything in the future will be addressed by the next phase of ACT. So others, anything else to chime in or add there?
So Song has a question, which is excellent, which is, for example, one probably doesn't want to rely on billing codes to identify ventilation timings, and that's absolutely right. They're not going to come in for maybe a week even after the patient's discharged. And so what often one wants to do is either find a proxy, like if you're on a ventilator, you're gonna have continuous arterial oxygen tests and carbon dioxide tests, as well as perhaps looking to import some special data into I2B2 just for that purpose, like flow charts on mechanical ventilators and so forth. So very, very good.
Thank you. All right, guys, other questions? That's it in the Q&A. Oh, here's one from Kelly. What is the frequency you aim to have sites refresh their data? So ideally, it would be once a week, even just on that specific COVID cohort, as Sham had talked about earlier. But we would love for sites to at least aim to do something more frequent than once a month.
I see something from Bill on the Q&A. Do you see that, Elena?
It's actually in the chat there. So Bill Adams is just saying that for us to substantially increase the frequency of our updates, we would need a new parallel process. Might ACT Central support an in the weeds meeting with folks who are successfully doing weekly or 2 times a week updates.
I think that's a great idea. Folks, let me see if there's anyone who would be unmuted that can answer this, who's doing it 2 times a week in the test network. But I think that that's a great idea to at least swap stories and share some insights and see what we can learn from each other. So yes, I will take that as a to-do. Thank you, Bill.